Chemical reactions happen all around us in our day-to-day activities. In these reactions, substances either bond or break, thus releasing or consuming energy. A chemical equation is a symbolic representation or shorthand that scientists use to describe a chemical reaction. The substances that react during a chemical reaction are called reactants, and the substances that are newly formed during the chemical reaction are called products. Chemical reactions are also explained through equations. Equations link the reactants with the products. Chemical equations are of two types: word equations, symbol equations. In a word equation, the name of the reactants are linked together with those of the products. But in a symbolic equation, these are described using symbols and formulae of the reactants and products. This equation describes the reaction between methane and oxygen that yields carbon dioxide and water. But is there something which doesn't add up? Yes, the equation is not balanced, so let's try to balance it. Let us now count the number of atoms of all the elements in the reactants and products in the unbalanced equation on both sides of the arrow. The hydrogen atoms in the reactant CH4 are 4, while in the product H2O the count is 2. To balance the hydrogen atoms, put coefficient 2 before H2O on the product side. Now, let's see if the equation is balanced. CH4 plus O2 gives you CO2 plus 2H2O. By balancing hydrogen atoms, the equation seems partially balanced. But oxygen atoms in the products is 4, whereas in the reactants the count is 2. So let's try again. To balance oxygen atoms, put coefficient 2 before O2 on the reactant side. That will balance the equation. Let's see what has happened. Now the equation is CH4 plus 2O2 gives you CO2 plus 2H2O. The equation seems balanced, but what about the carbon atoms on both sides of the equation? As such, the count of the carbon atoms on both sides is equal. Finally, we have the equation as CH4 plus 2O2 gives you CO2 plus 2H2O. Now the equation is balanced. The equation is made more informative by mentioning the physical state of their reactants and products with the help of certain specific symbols known as state symbols. These state symbols are S for solid state, L for liquid state, G for gaseous state, AQ for aqueous solution. If we analyze the equation further, we will be able to explain in which state the reactants and products exist. CH4G plus 2O2G gives you CO2G plus 2H2OL. Let's consider an example. 2NaS plus 2H2OL gives you 2NaOHAQ plus H2. Here, the gas evolved in a reaction is indicated by an arrow pointing upward. In another instance, where a precipitate is formed in a chemical reaction, it is indicated by an arrow pointing downward or by using the abbreviation PPT, such as CaOH2AQ plus CO2G gives you CaCO3 plus H2OL. Things to remember. Chemical reactions are also explained through equations. Equations link the reactants with the products. Chemical equations are of two types: word equations and symbol equations. In a word equation, the name of the reactants are linked together with those of the products. A chemical equation which is described with symbols and formulae of the reactants and products is known as symbol equation. An equation is made more informative by mentioning the physical state of the reactants and products.